We're going to do a little bit of a YouTube video on wire, marine wire, and kind of wire in general. But in particular, we're talking about wiring on a boat and the differences in household type wiring and marine wiring. Some differences, and on the insulation and the construction of the wire. This is not really that technical. This is general guidelines. You would refer to the there's a code that's used for boating. You can look it up on the internet. And also the other thing we're not going to talk about is current readings on capacity of wire, because that's easily looked up on the internet. Current rating of a particular wire depends on the length of the run. Is a significant factor on the wire. So the longer the run, you have to step up in gauge. You may have a 14 gauge wire, good for so many amps, and then if you make it longer, you have to increase the size of the wire because of voltage drop along the run. You usually look for a 2% voltage drop, and any greater than that, you have to go to a wire, larger wire size. But let's just talk about the wire itself, the construction, and the type of wire, copper. These are all copper wires, and we'll just talk about it. The first one is this first row, and this first row, they're all 14 gauge, and we'll talk about each one in particular. To start out with, this is a standard wire, 14 gauge, insulated, plastic insulation. Good for, certainly good for 12 volts. It's also good for higher voltages, probably good up for 250 volts. The thing that makes this wire a little different than the other wires is the strand count. I did count the strands. I have them bent over, and this has a 64 strand count. So there's 64 strands of very fine wire to make up the bundle for 14 gauge. And the more strand count you have, the more flexible the wire is. This is a very flexible wire, and the insulation is a factor in flexibility too. So this is a very flexible wire. It is not tinned. It can be used for marine applications. Some people talk about the marine gauge, marine type wire that's tinned. And that's certainly a preferred way to go, but that tends to run the cost up. Untinned wire will work, provided the wire is clean when you first strip it off. I've used untinned wire, and on the last boat I had, and it ran fine for 33 years. So I don't have a problem using untinned copper wire. So this is the first one. This is 14 gauge, 64 strands. Tends to be marine type, untinned. Now we're going to go to 14 gauge. This is like household wiring that you would see an electrician use. It is only has 19 conductors. It tends to be stiffer because of that, and the insulation is different. It's a different kind of plastic insulation, which also makes it stiffer. It's certainly good for 12 volts. It's good for 250 volts AC, but it's a stiffer wire, and this is the kind of wire you really don't want to use on a boat if you can help it, because it is stiffer, and it's really designed to be pulled through conduit for home construction and utility construction. So it's really not the wire that you want to use. Then let's just take a quick hop over to the standard household type wiring that you would see in a house, and certainly you don't want to use this kind of wiring on a boat. This is also 14 gauge, single conductor. You can see the conductor here. It's black and white, and a ground. You would never use something like this in a boat because it just doesn't terminate well. You really can't do much with it. It's stiff. What tends to happen is if you try to put this on a terminal vibration, and the wire breaks right at when you grip it. Sometimes you put a little nick in the wire, and the wire is going to fail right at that location. So you certainly don't want to use this in any kind of application where the vehicle is moving, a boat, a motorhome, whatever, because it's made for inside the walls on a house, and it's made not to be moved. It's usually tacked down. It doesn't move. And it's very stiff. This wire tends to be very, very stiff because it's single conductor. We're going to go to the next one, and this one is it's called the name of the wire is on it. It's Anchor, and it's marine wire, and it is tinned. The wires are tinned. It's a very flexible wire. This is a 3-conductor bundle. It's a very flexible wire. This has 41 counts or 41 strands per bundle, so this is a relatively flexible wire that's standard kind of in the marine industry. This particular one is a 3-conductor in a jacket. It's black, red, and brown, and this is would be used kind of for primary wire on a boat, and that's fine to use. It's tin. The next one is the same kind of wire, and it's a primary wire, 14 gauge, but this happens to be, again, non-tin, and it's a 19 conductors, 19 strands per conductor, so it tends to be stiffer, and I've seen this used on boats also. Preferably you use this. This comes available in a 2-conductor or a single conductor. You would tend to stay away from this because it's stiffer and it's more strand count. Now we're going to talk about multi-conductor cables, which I do have a total of 3 different ones. And let me move these out of the way. I'll put them over here on the end so we can look at them. Then we have multi-conductor cables. Now these are great for when you're making a run where you have a lot of, for example, the instrument panel that I built, I use this kind of cable. It's a multi-conductor. It is 10 conductors and 10 different colors, which makes it really nice because it's color-coded. This is 16 gauge wire, non-tinned. It certainly could be used for marine application. It's nice because it's a bundle with all those colored wires, and so you make one cable run and you break it out, and you go to your individual whatever it is in the instrument panel, wherever you have to. I tend to use a lot of this on the boat because it makes the runs very easily. If I'm running, say, from the generator control panel to the panel that operates the generator, which is in the nav station, I use this because I have to make one run and I have 10 conductors in one shot. This is relatively flexible, not as flexible as the other ones, of course, because it's 10 conductors, but it is flexible and it does pull through the holes that you drill for the boat. It works very well. This is interesting. These are 20. There's 20 conductors in this bundle. They're all black, and you would say, well, how am I going to know that? But they're actually numbered. Each one has got a number on it. It goes from 1 to 20, and it has a yellow-green wire, which is considered ground. This is very flexible because it's lighter gauge number 1, and it's got 20 conductors, but it flexes very, very readily, and it does work very nice. This is not used as much on a boat. It certainly could be. They tend to use one with more colors than this one. This is an older style, and it could be used. I mean, I don't see a problem with it. The generator that I had on the boat was a Fisher, which is a German generator, and it used this kind of wire. It had numbers on them, and it was fine. It worked. So now this is multi-conductor cables. 16 gauge, 20 gauge, and this is 20 gauge also. Now let's talk about single conductor cables, for example on a bow thruster or a windlass or battery cables. We have, over here we have 4 different types. Now let's talk about the first one. This is a number 8 wire, and this one has 49 strands of wire, non-tinned. This would be used and it's certainly usable on a boat, even though it's non-tinned. It's flexible. You can see that's 8 gauge. It's very flexible, and you know, you would use this in areas where your current draw is going to be higher. I've seen used on some windlasses. Certainly not a bow thruster because it's not enough gauge, but it would work on a windlass. It's available in different colors. So this happens to be a green and yellow tracer. That usually tends to be for ground, and this will work. Would work fine. I did use some of this on the boat. Then we go to a number 2 wire, which you would never use on a boat. This is utilities, service entrance for utilities. This is a number 2 gauge wire. There are, I did write it down here, there's 19 individual strands of copper. Very, very stiff. two things that make it stiff: the wire itself, the way the wire is wound, the way the copper is inside the jacket, the way they wind it makes it very stiff, and the insulation makes it stiff. It's like a solid bar. I mean, I can't even begin to bend it. You would never use this on a boat. It's just too heavy gauge, and it just is not doable. The next thing that you would use on a boat is this is the same gauge. This is 8 gauge wire. I'm sorry, I said that wrong. This is 2 gauge, and this is also 2 gauge wire. And this is, as it says right here, the insulation is good for 600 volts. It's 2 gauge wire. I didn't count the strands, but there's hundreds of strands here of copper. And it makes it very flexible. You can see I'm bending it, where the other one I couldn't even begin to bend it. I've used this on windlasses, and this could be used on bow thrusters depending on how long the run is, and depends on how big the bow thruster is. Certainly it will be fine on battery cables. Again, depends on the length of the run and the size of the starter, the engine. On a sailboat, it's not usually a big starter, so you don't need that heavy battery cable. And the next one we're going to talk about, and of course there's wire sizes in between. The next one we're going to talk about is this one, and this is called 3/0 cable. That's 3/0 cable. Again, this has numerous strands. I didn't count them, but there's hundreds and hundreds of strands. The way the wire is wound, there's sub-bundles, and in that sub-bundles there's fine strands. It's very, very flexible for number 2 as compared to this is a number, this is a number 3/0. This is a number 2, and this one is not flexible, and this is 3/0, which is very flexible. Some guys refer to this as welding wire. This tends to be more expensive, of course, the more copper, and this is what I used on my bow thruster on the boat. The bow thruster draws 400 amps, and obviously you're not going to run that all the time. It's just in bursts of 30 seconds. But because of the length of the run, you had to go to 3/0. I did use this on the boat because a lot of guys will put a battery forward by the bow thruster, and I didn't want to do that because that requires charging a separate battery, and it just made the installation a nightmare. So it was certainly easier just to run this wire from the battery bank through a safety, through a disconnect switch, through a fuse to the bow thruster. The runs weren't that long, and this wire did a nice job doing it. It was very flexible. I was able to snake it through the bilge area and through the grid on the boat. So this worked out very good for a bow thruster. So that's kind of it, and it's got a rubber jacketed insulation. It's certainly good for the voltage. 12 volts is not an issue. That's the one thing about low voltage. You don't have the issue of worry about the insulation. You certainly don't want to nick it, but this would work very well. So that's kind of the wrap-up on wire. Again, since I had some questions asked to me about different wire, I just wanted to present it to you. On this wire, like for example, on the heavier gauge wire, what I tend to do is I'll make my own ends. What I do is I take copper tubing, depending on which size end I have to make. I'll take a piece of copper tubing, soft copper that you buy at the Home Depot. I'll go inside the tubing with a brush and clean it with a wire brush and clean it real good. I'll flux it up, and then I'll take the length of the copper I need. I'll cut it off. I'll hammer one end shut, drill a hole for the bolt, and then slot. And then I won't crimp it. I tend to solder it. What I'll do is I'll flux the copper terminal I had made. And you can also buy these at any welding shop. They have these pre-made copper terminals. They're meant to be crimped or soldered. Most guys don't have a crimp tool for this gauge wire, so I tend to solder it. What I do is I heat it up with a propane torch, one of those little benzomatic torches, and I flux the copper real good. I flux the cable. I make sure that this fits real nice inside the copper tube before I start, and then I flux it and I heat it up and I solder it and I fill the copper cup up, which is the back section where the wire goes, with solder. I keep it hot, and then I slide this inside and continue heating, and the copper wicks up into because this is flux, the copper wicks up, and it doesn't really travel up far into it. It may go just a little bit up inside, And that's my method of doing it, and I've done that for years, and it works out great. I've done it with this size wire, and also this size wire. And the same method, depending on the size of the end that I want to make, I use smaller copper. You could certainly go out to a welding supply, or Harbor Freight actually sells the ends, the copper ends with the holes in the middle, but I tend to make my own because it's just convenient. So that's pretty much it. One of the other things that we talk about is crimp terminals, and I don't have any with me right now. But when you crimp a terminal onto the end of this wire, the spade terminals or the rings or whatever you use, one of the problems I found out is unless you have a calibrated crimp tool, which when I worked in aerospace, they used to have guys that went around and calibrated the crimp tools and also calibrated the strippers, and if they didn't meet calibration, they didn't get used. Obviously, nobody has that in their toolbox. Those tools are very expensive. So when you just use your standard crimp tool for the red, blue, and yellow, the type of tool you see for the red, blue, and yellow crimps, what happens is when you crimp it, I've seen it several times where you use the right size wire, you crimp it, and then you put a little pressure in the crimp terminal, it pulls right off. And most people don't realize that they crimp it and they put it in place and everything is fine, and then you get a little corrosion under it, and then before you know it, you have an intermittent contact. I tend to do two things. After I crimp it, I tend to flux it, and I do solder the end of the terminal, and I make sure when I put the solder in, I don't put a lot in so the solder doesn't wick up inside. We talked about that earlier. The solder may wick up very little, about 1/8 of an inch, if you don't use too much solder. And then you're guaranteed a connection that will last you your lifetime and the lifetime of the boat, because the corrosion won't occur in this area where it's crimped. And vibration won't be an issue because it's right up against the crimp terminal itself. It's not wicked back up into the wire, which tends to make it stiffer and more brittle. So that's the way I do mine. And again, the last boat, 33 years, that's the way it was done, and that worked out fine. So that pretty much does it for the wires. If you have any questions, just make comments on the YouTube site, and if you have any questions, I'll be happy to answer them. And that should do it for now.